All right, in example 4, f of x is the square root of x. And what we're asked to do first is to sketch a graph of f of x and the tangent line at x equals 1. All right, so first of all, let's just graph what f of x looks like. It's just a square root, right? So now I can't take the square root of a negative number, right? So the square root of 0 is 0. Square root of 1 is 1. Now, I'm not going to bother trying to figure out what the square root of 2 and square root of 3 are. I could use my calculator, but it's much easier just to find values of x that are easy to take the square root of. So I know the square root of 4 is 2, and the square root of 9 is 3, right? So make it easy on yourself. Don't try to put in values that where you have to use your calculator. You might not even have a calculator if this is on a quiz or something, right? So choose values that are nice. All right, so now I'm just going to sketch this graph. So I'm just going to kind of connect up these dots, right? So we'll just connect that up. That's what it looks like. And then we're also asked to sketch the tangent line at x equals 1. Now, let's see if I can draw a decent tangent line. I think I'll change the color of it. And, all right, so let's see how good of a tangent line I can draw here. Okay, there we go. Good enough. All right, so there's our tangent line. So now the next question says write the equation for the tangent line at x equals 1. Okay. Now, we've done this before, right? The equation for when we are trying to write the equation for any line, if we have a point and a slope, then we can write, we can use the point slope formula. So I know that f of 1 equals 1, right? So our point, the point is 1 comma 1. And f prime, all right, so now I need also the slope, so I need to find the derivative. So first of all, find f prime of x. We have the square root of x, which is x to the 1/2 power. Now you can either write it as 1/2 x to the minus 1/2, or if you remember that this is also 1/2 square root of x. Sometimes that's handy. And then I can find f prime at 1. Okay, so f prime of 1, I'm just plugging in x equals 1 into the derivative, so I just get 1/2 times the square root of 1, so that's just 1/2. So I didn't leave myself a lot of room here, but I can use the point slope formula, right? I do y minus the y coordinate of the point equals 1/2, and then x minus the x coordinate of the point. And then I can rearrange this. Let me just write it over here. Let's put it in the point slope formula, or point slope form. Well, actually, let's not. I'm going to do this. I'm just going to add 1 to both sides, right? So I get 1 plus 1/2 x minus 1, right? I'm just going to leave it that way. All right. All right. So the next part is asking us to find the equation for the linear approximation for f of x equals the square root of x near x equals 1. So in this case, it's asking for a linear approximation. I am just going to use that formula that I have, right? So f of x is approximately equal to f at a, but our a is 1, right? This is a. This is a. And so f at 1 is 1 plus the derivative at a, right? So I know from my previous problem that f prime, I know f prime of x, and the derivative at 1 is 1/2. And then I have x minus a, which is 1. Okay, so look at that. It's the same thing, right? The tangent line, the linear approximation, it's the same thing. So that's really the only reason for asking this twice, is that formula that's in the box right up above is the same as a tangent line. I kind of like this formula just because it's easier to I don't know, it's a little bit easier to use. All right, so this is the same as, oops, as the tangent line. All right, so we can use either one. Then it says, without a calculator, use this linear approximation to estimate the value of the square root of 1.1. All right, so this, right, our linear approximation here, remember our f of x was the square root of x. And this linear approximation is approximating square root of x near x equals 1. So 1.1, that's pretty darn close to 1. So all I need to do now is just substitute x equals 1.1, and I'll get an approximation for the square root of 1.1, right? Because my f of x is approximating, or yeah, my polynomial is approximating the square root function. All right, so I'm just going to take 1 plus 1/2 and then 1.1 minus 1. Okay, so that's 1 plus 1/2 times a tenth, right? Because 0.1 is a tenth, so that's 1/20th. 1/20th is 0.05, right? So, or I could just say, okay, 0.5 times 0.1 would be 0.05. Or you could use your calculator. But it says without a calculator. So sometimes that's a little challenging. But we get 1.05. So again, probably the easiest thing to do is just 1/2 is 0.5, and then this is 0.1. So 0.5 times 0.1 would be 0.005. All right, so that's our approximation of 1.1. Oh, sorry, the square root of 1.1. Right? We did this without a calculator, right? I don't know what the square root of 1.1. I'd have to use my calculator to get the exact value, but this is just approximation. Now, the next question is asking, is your approximation an overestimate or an underestimate? And how can you tell that from the graph? Well, let's look back up here at the graph of the square root of x and the tangent line. Now you can see that the tangent line is above the graph, right? Our square root function is concave down, right? So it's curving away from the tangent line. So if we use the tangent line as approximation for the square root of x, it's going to give values that are too big. It's going to give overestimates. So I am just going to say, scroll down here, it gives us an overestimate. Okay, and the reason is that the graph of the square root of x it has to do with the concavity. Concave down. So when it's concave down, the line, right, the tangent line, the linear approximation, which is the tangent line, the line is above the graph, right? All the values, the y values of the line are bigger than the values of f of x, which is the square root of x, above the graph of the square root of x. Okay, so it's an overestimate. Now we can actually just use our calculator now. Let's just use our calculator here. This is kind of an aside. So I'm going to say, okay, using a calculator, we can actually take a look at, how good is that approximation. All right. So what I can do is just take the square root of 1.1, right, using my calculator. If I put that into my calculator, I get that it's approximately, again, I'm rounding off, right? This even is an approximation because the decimal places just keep going and going. But I got 0.0488. Okay, now that's a better approximation because I just put it in my calculator, so I've got it accurate to more decimal places. But just using the linear approximation, that's not too bad, right? Depends on what you're going to use it for, how accurate you have to be. So it's kind of a cool way if you don't have a calculator, and you know some calculus, you can approximate square roots with this little linear function. We could have simplified this and made it 1/2 x, right? If I distribute this, minus 1/2 and then plus 1, so we'd have plus 1/2, right? So this is just a simple linear equation, 1/2 x plus 1/2. And so that's pretty slick. All right. I'll meet you in the next video.